Hey y'all, it's Mr. Boyd, and today we're going to talk about how to find angles. Really, it's not so much about finding them. We're just going to talk basically about what angles are and some of the properties they have, and then how we name them and show that they're congruent. So let's start here. We have an image down below. We have a picture of an angle down here. Notice some vocab is labeled. They've told us that the point where the angle occurs is called the vertex. And then we also have sides of the angle. Those are the segments, or actually, let's fill in the blank up here. So an angle, notice that's bold, that's a vocab term. It's formed by two of something that share a common endpoint. Okay, now that's the common endpoint. It happens at the vertex. In here, it's case A. So what are these things going off? They start at one point. They go forever, so they are, in this case, they want us to say two rays. Though, y'all, honestly, if you thought segments are lines, those make angles too, and so you're right. Okay. It is important to know that an angle can be named with either one or three letters. Three letters, you can always use that. One letter only sometimes. Let's look at why. Okay, or let's look at the example for this one. So this angle down here, it could be called angle A, and notice the symbol I'm using there. That's not less than, or you could call it angle TAP. Here's what angle TAP means. It means an angle that if you trace from T to A to P, you traced over the top of that angle, and we did that. Now I do want to give you an example of what would be a wrong way to name this angle. For example, what if I said angle TA? That would say to trace from T to A, and what is that angle? Well, that's not an angle, that's a segment. Okay, so that doesn't work. Another wrong way to name this would be to call it angle T. That would be wrong, because actually there is no angle occurring at T, it's just a point, versus there's two things coming together down here at A. That's why it's an angle. The third wrong way, and guys, I see this one a lot in class, especially for students that are just learning this, they'll do like angle PTA. Let me show you why that doesn't quite work. Because what that says is to trace from P to T to A, and you see how I went across the middle of the angle? That means I didn't trace on top of the angle, I went across the angle, so that doesn't work. So two of the right ways to name the angle are over here. Let's do another example. I suggest you pause the video so you have a chance to draw these in your notes. So go ahead and pause now. All right, let's name all the angles in the drawing, and oh my goodness, there are quite a few. Okay, on this first one, we have an angle in here. I could call it angle 1. I do want to point out to you that I cannot call it angle U. The reason why U is here, there's more than one angle that occurs at U. There's two angles, and so if we call it angle U, then I don't know which one it is. Okay, so I can't do that. What else? There's an angle down here. I could call that angle T. That's another angle. Down here, I could call that angle V. And notice there's only one angle occurring at T. That's why it's okay to use one letter. Now I want to name this one in here that I'm about to write down in green. And again, I can't say angle U because there's more than one angle there. But what I could do is angle T to U to V. So angle T, U, V. If you haven't answered the next question yet, try it based on what we just did. So pause the video and try it, then hit play to see how you did. Okay, here's what I think it should be. Okay, over on the right, notice all the angles come from A, but there's more than one, so we're required to use three letters. So what I'm going to call this angle over here is angle XAY. Now, just so you know, it's okay if you put YAX. That traces the same segments. That's totally fine. And then the angle on the right, I'm going to call that angle YAZ. And again, if you put the letters in reverse order, that's totally fine. Okay, so that's just a little practice. That is how we name them. All right, let's add a little bit more vocab. Which angles measure more than 90 degrees? I want to remind you that a 90-degree angle looks like this. A 90-degree angle is the letter that is in a capital, or excuse me, the angle that's made when you write a capital letter T, or a capital L, or a capital H. Okay, so these are, let me draw a capital H up here just for good measure. Okay, and so we're probably pretty familiar with these. 90-degree angles, and write this down, it's a vocab term. They're also called right angles. And it looks to me like angle 3 might be a right angle. And so I'm going to make that note here. That looks like it's a right angle. And they said, which angles measure more than 90? Do you know which one it is? Okay, the only one that measures more than 90 because it's more open, and let's see how pointy that is. Pointy means it's a smaller angle. This angle right here is not very sharp. So that is more than 90. and you may have heard the word for this. Probably you have. The vocab word for that, and you need to write it down. This is the word for an angle of more than 90 degrees. That is an obtuse angle. And then angle 1 is less than 90. And so we call that an acute angle. An easy way to remember this, you go, oh, it's a cute little angle. It's small, it has a small number of degrees, it's a cute little guy. It's a cute angle, okay? That is the deal with that. All right, what about angle congruence? Okay, when we talked about segments, if we said they were congruent, it meant they were the same length. So now if we're talking about angles, we say that they are congruent if they have the same number of degrees. Now they gave an example right in here of how to mark two angles, and they see the DOG and CAT over here. They have the same mark. There are other ways to do that mark, just so you know. I could have a pair of angles like this, and I could mark them both with just a single without the tick mark. That's a different marking. Another way of doing it is I could do a double marking. In fact, you've seen me do that in this video already. As long as two angles have the exact same markings, then that means they are congruent. Okay. Now, what is up with this? This says congruent, this says equal. This M right here, it stands for the measure, which is measure, I should spell it correctly, which is a shorthand way of saying the number of degrees. So what this is saying here is the number of degrees in angle DOG is the same as the number of degrees in CAT. It's comparing two numbers. That's why it says equal instead of congruent on that. Notice down here, there's another vocab term, angle bisector. Okay. The word bisector, what that means is to cut in half. It's something that's cutting something in half. That's what that bi is for. It's saying that it cuts into two equal pieces. So to cut in half or two equal pieces. So the angle bisector here is this ray, which is giving us these two congruent angles. And look how they're marked. Those are the same angle. Now let's try an exercise. This is a good chance for you to see what you understand so far. So pause your video so you can write this down, try to answer these questions, and then compare your answers to mine to see how you did and hopefully learn from it, or to learn that you totally understand this so far. Here we go. Part A, name each angle bisector and the angle that it bisects. Hold up, in this first one, these two angles are not the same, so there is no bisector here. So it's kind of a trick. What did part B say? Name all congruent angles in the figure. There are no congruent angles down here. They have different numbers of degrees. Use the congruent symbol. Nope. So actually, neither of these questions apply to A. To the first one. Let's go to the second one. Now here we have 52 and 52, so we do have an angle bisector. So the bisector is the one that's going down the middle, right? That's what we saw on that last page. So what I'm going to write is that the ray RP, it bisects the angle, and it's cutting the big angle. So I'm going to name the big angle, so SRQ. And because of that, angle, so I'm going to pick the one on the left, SRP, is congruent to, same number of degrees, as angle PRQ. Now, comparing your answer to that, you're not allowed to have a single letter. Why? Because there's two different angles that are happening at R. And if you don't give more letters, we don't know which one you mean. Now, as far as how the way you wrote it, if you did PRS, if you said it backward, that's totally fine. That's the same angle. Or if you said QRP on the right side, that's totally fine. Let's go to the last one. Name the angle bisector. All right, guys, this one's really tricky. I don't think there is an angle bisector on this one, even though there are congruent angles. Because, for example, let's say that you thought that MN was the angle bisector. Well, what is it that's getting cut in half by MN? It's kind of weird because we have this angle over here, but it didn't cut the big angle in half because you get this blank space in here that's something different. So that's not a bisector. What about this one? Is that a bisector? No, because you don't have the exact same angle on the other side of it. So no, there actually is no angle bisector here. However, there are congruent angles. So no bisector, but angle Y, and I'm taking the ones with the markings now, y'all, YMN is congruent to angle OME. So, good enough for that one. In the previous video, we talked about something called the segment addition postulate. And all that meant is that if you have two segments and you add them together, or if you put them together, it adds their length together. The same exact thing is true with angles. And that's what all these words say. It's just saying if you have some point D that's on the inside of an angle, when we're talking about the angle, we're talking about this angle. Okay, and then all of this stuff, it says angle CAD, so if you take the number of degrees here, let's make up a number just so it's easy to illustrate it. And angle DAB, let's say it's a little bigger, that's 30 degrees. If the two angles are next to each other, then it's totally fine to add up those degrees and say that the bigger angle is 50 degrees. That's all angle addition means. Hopefully that's kind of intuitive. If not, here's a basic example involving pizza. So in pizza, if you have a slice with a central angle of 140, and they're trying to show us that here, that you want to share with a friend, yeah, of course we want to share with friends. She cuts through the vertex and cuts it into two slices. You choose one slice that measures 60. All right, hold up. Let's actually slice this pizza. What color is going to show up well here? So that's not great. Let's pick a better color. All right, so I've sliced it. We have one slice that is 60 degrees. We chose the one that's 60. It asks how many degrees are in the other. Well, y'all look, they just told us that the two together have to make 140 degrees. And so if you've got 60 down here already, you need to get to 140. I know that a lot of you can intuit that this is 80, and that's right. But like the technical way, if you wanted to show work, I mean, intuition is great, but if you want to show work, we'd say the whole slice is 140, and we just took away 60 degrees from it. So what's left over is 80 degrees. That's a simple example of the angle addition postulate. And you'll actually, they don't get a whole lot nastier than that. It's just the concept that if you put two angles together, you get a bigger angle, okay? All right. Now we're getting into the types of questions that we would actually have to deal with on an assignment or on a state exam or on a class exam. Okay, so here it is. Guys, I'm going to ask that you pause the video and you draw this and try to answer the question yourself. All right, let's see how you did. We want to find the measure of angle RTX. Let's locate that on the diagram first. Angle RTX. So I'm just going to kind of draw over that to make sure I know exactly where that is. Now, what I notice right away about RTX is that it goes from here to here. It goes across 120, but also another angle. So if I know if I know how many degrees are in that angle, then I can use the angle addition postulate to just add those two together and get the answer. So really, I need to find this angle right here, and then I'll be able to answer this question. So I want to go back for a second before I drew all that. Notice that if I go around and I trace every angle, so I'm going to trace this angle, and then we'll trace the next one, and trace the next one, and trace the next one. Okay, that was a terrible drawing. But it goes all the way around, right? So that kind of makes a circle. If you go all the way around a circle, you have gone 360 degrees, yeah? So what that tells us then is that all the way around this picture, all of the angles added together must add up to 360. Well, let's start taking away angles. And when I say take away, guys, I'm using that to kind of hint back to elementary school when you might have said, maybe you learned this as 5 minus 3. Maybe you learned it as 5 take away 3. I'm literally taking away like sort of slices of pizza here. And so I'm going to take away the 135, and I'm going to take away the 62, and I'm going to take away the 120. So take away, take away, take away. What's left? What's left is the angle or the sort of the slice of pizza that I was interested in the first place. So now I'm going to type that in my calculator. And as I'm typing that in, I noticed that I forgot to put the 0 on here, so I better include that. And I got 43 degrees. Now I put that on the picture. That looks about right, so I'm not feeling too bad about it. But keep your eye on the prize. 43 is not the answer to this question, because remember, it asked about angle RTX. We just found RTS. So let's go back to RTX. All right, that's 120, that's 43. 120 plus 43 equals 163. Now that would be obtuse. Does this look obtuse? Yeah, that looks about right. Yeah, so absolutely, the answer is 163 degrees. All right, y'all, that's going to be enough for our introduction to angles. I hope you enjoyed the video, and I'll see you next time.